Hello, Catherine. Good to see you. Good to see. Hello, Brandon. Good to see you.
Good
Good.
morning, Professor.
Good morning. Good morning. Good morning, Colin. Good to see you.
Hey, morning.
Good morning. Good morning, Xavier. Good to see you. Good. Uh, good morning, Good morning. All right. Good morning, Charlene and Alexis. Good morning, Anissa, Ariana. And I'm doing the chat. Good morning, Gaia. Good morning, Chanel. Good morning, Charlene with the double. Good morning, Anissa with the yeah. Good morning, Nasreen with the double. Um, good morning, Adenelsi. Morning, Ryan. Good morning, Alexis with the double. Good morning, Michaela. Good morning, Carolina. Okay, let's. Okay, good morning, Alexis. All right, all right. Let's get rolling. What I'm going to start doing today, and I will continue to do Wednesday. I mean, I think it's the least I can do, and it's the most I can do. Wait, hold on, someone else is here. I I'm going to go straight to the practice midterm, like right now in a second, and I'm going to start talking through one of the big problems, the practice midterm, uh, that I think is one of the more involved, harder problems. One of the ones I'm going to go over one of the problems in a minute, the one that's from the most recent material. So the one that I think you might find the most challenging. Um, so I'm going to do that in a minute. Hopefully that's helpful to your ability to do the midterm. Um, I may, and I'll walk you to it. And anyway, I'm going to make some I'm going to open up the and screen share the practice midterm in a moment. um, and do like a quick walkthrough of comments until I get to the problem I want to go over, and then I'm going to go over that problem. So again, this is part of the whole thing of like, I'm not, this is part of the whole philosophy or approach, good or bad, which is that your actual midterm that's going to be posted will be very similar to the practice, not identical, but very similar, certainly cover the same types of things, certainly in a very similar way, etc. So the one thing I don't do is just like literally give you an answer key because because that would defeat the purpose on many levels. But what I do is say you have access and entitlement to take all this time to find whatever answers you want or figure out how to solve these problems. If you and I will help you however I can. Like today, I'm going to basically walk through one of the problems, not all of the problems, but one of them. Okay. And I think it's one of the harder ones. And Wednesday, I'll do a different one. Oh, so I hope you get the point. Like there is no literal answer key because your midterm will be so similar to this that that would defeat the purpose. But you are allowed to find any answers and solutions you want from old videos from me right now, etc. Also to remind you, I believe it hasn't happened yet, but I believe the MSRC is holding a review session, I think, this week, or maybe they already did. You can tell me in the private. Sorry, sorry. Wait. Oh yeah, wait. And yes, I thought I already did that. Sorry. Yes, I see the direct chat. That's not awkward. That's totally reasonable. And it's my bad because I thought I already did that. Yes, yes. Um, Yes, someone's reminding me that homework 8 is due the exact same day as the midterm. That is not on purpose. I will change that right now. No, from here on in, I just want you to focus on the midterm. Absolutely. And if you're behind on old homeworks, you should worry about them only to the extent that they like help you practice and get up to speed for this midterm. Like you should be using the practice midterm as your focus from here on in. And then, yes, if you see something in the practice midterm that reminds you of homework that you like never did or never felt clear about, sure, this would be a good opportunity to go back to that and straighten it out and get more points or whatever. But you're, but I'm not removing any portals or anything like that. Any back homeworks and stuff you could still do after this midterm. And so I hope you get the point. Like it, you should just be focusing on whatever helps you with this midterm from here on in. And that's what I'm going to be doing with you too. Hold on. So right now I'm going to change that what the direct chat person just said. And then I have a couple of questions. And can you tell me in the direct chat, one of you, hold on, I'm just getting to it. Sorry. I will change that. And also, can you tell me in the direct chat about who your lab instructor is? I forgot. I'm sorry. I don't, is it Walt? No, it's not Walters. Just tell me that, is it Walters? Just tell me in the direct chat who your lab instructor is and what's the deal with the MSRC review session? Like, did it already happen or is it happening this week? If someone could remind me. And hold on, but I'll fix that homework right now. Oh yeah. Yeah. Okay, I see. Okay. I'm literally, and that homework is long. I see your point. Yeah, absolutely. So I'm changing that to the week after the midterm. So I'm extending it by a week. And homework 7, I do understand was due today. But that's very relevant. Like even if you did a thorough, if you, and I know I'm behind with you guys with feedback and stuff like that. I am, no question, and I apologize. But right with homework 7, as long as you tried it and handed in something, you could still get more points later or whatever. But it was worth homework 7 is like very good practice for this midterm. So that whatever. Anyway, so I just changed homework 8. Thank you for. Okay, and homework 9 is still. I may make other adjustments later, but everything is okay for the moment. Wait, I'm looking back in the chat. Uh, oh, it already happened. Okay, thank you. Okay, it already happened. All right. Well, the good, all right. Well, the good, I hope, oh, when you have tally. Yeah, okay. Hold on. I'll write her a message right now. And when do you, it, did many of you go to, well, I don't want to get too, I guess I'm curious. Just raise your electronic hand if you went to the MSRC review. It was obviously it was optional, but I'm just curious. Just raise your electronic hand if you or maybe it's not my business. I don't know. But okay, I hope it was helpful. If you did go, I hope it was helpful. And whatever. And well, I guess I am. Could someone just tell me in the direct chat if anybody went? Tell me in the direct chat. Geez. It was at the same time as it. Okay, but somebody did go, and it was helpful. Okay, good. And quick question: they use this document. Oh, you made a one-on-one session. Okay, that's cool too. I mean, I guess what I just want to confirm, they were using this, they had access to and were using this practice exam. Yes? Well, all right, I'm gonna get rolling in a second, but okay, you made a one. Oh, when do you have lab this week? I mean, when do you always have lab? Like what day?
Tomorrow, Tuesdays.
Tomorrow. Okay. Okay. Did she say any? I just sent her a message, just like this second. Um, did she indicate anything? Do you have any sense of, do you know what you're doing tomorrow in lab? I'll take that as a no, which is fine. I mean, we don't yet. Okay. I just sent her a message. You're assuming it's lab 5. I mean, that's a good assumption. You did a board meeting. Oh, wait, this is good to know. You did a, okay, sorry. What'd you do the board meeting on? Oh, on Newton's, probably. Oh, I think I know. You did a board meeting on like the free body diagrams and the system schemas. Yes. Low key. Low key. All right. Okay, cool. All right. So this is good to know. I'll get rolling in a second. I just want to make sure we're on the same page. So just to be super clear, like, yes, you're moving ahead in lab. That's good. That board meeting. I mean, and someday if we had lots of time, I'd love to know whether you enjoyed it or not, whether it was good. Like, I'm a big fan of board meetings, big fan. But I know they're very hit or miss. They're either like amazing or they are terrible. But one quick I will say about board meetings, the thing about board meetings is often, even when they feel terrible, even when they feel like nothing is going on, that's when actually the most is going on that you don't realize till like weeks later. But whatever. So if it happens that any of you walked out last week, like what the what, it may be that it scrambled the depths of your understanding in ways that you won't appreciate until you take the exam or whatever. So don't give up hope is all I'm saying. But um, yeah, right. I mean, they can be okay. It was fun. It was awkward and quiet. Yeah, again, and I love, and I'm in my office on Tuesdays from 11 to 1 or thereabouts. One day when we all die, I would love to catch up with some of you or hear more about these things. I mean, I love hearing about board meetings. And yes, they are often very awkward. And it doesn't mean they're not productive, but yes, they can be very awkward, but they can also be fun. All right, wait, I'm just looking at, oh, great. Oh my God, she got back to me so fast. Okay. Okay. So I will get rolling with what I want to do with you in a second, but just so you know, so we're on the same page, I just messaged Tally, Mercedes, and she will do a review session with you guys tomorrow in lab, like instead of during lab period, okay? And she does them differently, different semester. Like it will be her approach. I don't know whether she'll give you time to work on the practice in group, like whatever. I mean, I might talk to her tonight, but it will be her approach. But whatever it is, I can tell you right now that tomorrow in lab will be time dedicated to you working through this practice exam. She too, it's not like I give her like an official answer key or something like that. But obviously, she knows her physics and all of this. So she's she'll answer any questions or she'll do whatever she does. But it's free game for all of you to just try to like rip this practice midterm to shreds. And which is what I'm going to start doing when I shut up in like 7 minutes. I will at least try to rip one of the problems. Well, try to guide you through one of the problems today. And let me say also, this is so weird, but like years ago when I gave practice exams, years ago, people would ask me, okay, so if we know everything in this practice exam, does that if we can get 100 on this practice exam, like are we guaranteed to get an A on the exam itself? Right? And years ago, I would get all defensive and say, well, I mean, like, no, I'm telling you, if you can't nail this practice exam, then you won't be able to nail the real exam. But I'm not saying that doing this practice exam perfectly is all that you need to do. Blah, 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 blah. But truthfully, if you really do know this practice exam inside and out, I mean, no, real, not just like you can tentatively like write down answers that you sort of know are right, but you don't really get. But no, if you really get the inside and outs of this practice exam, oh yeah, you will nail the exam. Like it is that straight. Like in other words, put all your attention into this practice exam. Like until the exam is posted. And once it's posted, you'll see you're not going to be that surprised or thrown or whatever. It's just going to be like tweaking what you did here. And so hopefully, if you do this one with care, you can treat the practice exam sort of as your rough drafts for a final copy that you'll put together very neatly and thoroughly and lengthily for the actual exam. Okay. Now again, and I will get rolling in a second. Again, uh, I'm going to give you my thoughts on this problem. I'm not, whatever. You have to do it your way. You have to do 5-step method and make it as clear as possible that it's filtered through your brain to your fingertips. Like, you get my point. But I will show you. Wait, you're not cooked. You're totally not cooked. No, you really are not. The one thing that's like slightly bad news, well, slightly update because, well, did I do this? I think I did change one thing in the announcement. Let me just see if I did that. Yeah. One thing I did have to do because we don't have school next Monday and you're not turning this thing in all the way until Wednesday, right? I did make one adjustment and I apologize. I just want to be clear, and it's clear in the announcement, but you may not have seen it. I'm not posting this thing Thursday night. I'm posting it Friday night. Okay, it's kind of like I apologize. So you can't start until Friday night, but that's also I did that so that all the classes can have opportunities in this is not the only class of physics that so that all of them have opportunity to review during lab and all of that and give you all an extra day with the practice. Anyway, the basic reason, so but you'll still have more time than most people have most semesters to do the thing because you're not turning it until Wednesday rather than Monday, but it won't be posted until 8 p.m. Friday rather than 8 p.m. Thursday. That's just is what it is. But okay, wait, how? I know. I am a terrible person. Okay, what I'm gonna do now though is I'm gonna turn to I'm going to switch the screen share. I'm going to switch that that person who's in the direct chat right now. I'm just saying you have a job waiting for you on the other side of all this. Many of you do. Well, you all do, but some of them are with me. Okay. Okay, I'm going to switch to screen share. Okay, I'm not even fair enough. Don't get me started on that. Wait, I'm switching the screen share so we can look at the exam together. But the next 2 days are all about the exam as far as I'm concerned. And if I sound a little edgy, it's because I don't like exams any more than you do. But I believe in them. But that means at any time you really should ask questions. And the shorter and simpler they are, the faster I'll answer them and keep going. But it is about you. Like this is about my whole goal, no matter what, is for you to do as well as possible legitimately on this exam. I mean, I hope that is clear. So that is the goal. So wait, I'm pulling it up right now. Pulling it up right now. Okay. Um, okay. Oh, there's something in the chat. Wait. Oh yeah, okay, wait. So first of all, absolutely you have to yes, you got to use the five-step method on the exam. I will try my best right now to model it for you as I've tried often in the past. But oh yes, the purpose of the five-step method, like that you've been doing it on homework, was to be practicing for the exam. You definitely want to do the five-step method on the exam. You want to go overkill on the exam. Like honestly, it's you want to go overboard with breaking everything you do into steps. Think the five-step method is almost just like the template reminder to you to break things down into steps. Many of you are going to find, especially like with step 4 and stuff, step 4 is going to be divided into lots and lots of steps. I don't want to sound harsh, but like the five-step method is kind of like the skeleton for what you have to do. And not only should you do it, but you should label as you go, step 1, step 2. Think of the five-step method as the way you are making it as easy as possible on me to give you, to record for you as many points as possible on this exam. Like, really. Like, that's what I'm going to be looking for is where's their step 1? Where's their step 2? Where's their step 3? Like, honestly, and at the beginning of the exam, go overboard in explaining things. Once questions start getting repetitive or short and exercisey, sure, you can do a lot of like see above, or once you've explained a thing, you don't have to keep explaining it. But think of this whole thing as a presentation to someone who doesn't know the insides of your mind. You're trying to show me the insides of your mind in the document. So once you go crazy at the beginning of the document, you should trust me that I'm still with you in that document. But I don't know anything about, but assume that I don't know anything besides physics and the document you give me. Like I don't have any other documents next to me. I don't have the questions. I don't have your other homework. Like I wish I did in a way, but I don't. right? So you are spilling out, you are taking me on a walk through your understanding of these physics problems in the document. And so, yes, please. I mean, I'm not, but I just saw a question in direct chat. So I want to, yes, you're doing the 5-step method, like, and you're labeling it as you go. And you're using different colors and you're commentating, like make it a presentation, a final. And that's why the whole purpose of the practice exam is like you're practicing your presentation. I don't mean a spoken presentation, but right, this is like a presenting document. So everything you're doing with the practice exam is not wasting your time. And it's not like an example. It's just like leading you so that by the time you get the final exam, you're looking at it, you're like, yeah. Okay, I know what to do. Right. And you're making a beautiful, easy to follow document for me. I hope that's clear. Okay, wait. So wait. No, right. So wait, and I don't want to, these are good questions. So I will get going in a second. Wait. Right, no, that's not dumb. Hold on. Okay, these are good questions. Hold on one second. Things are happening on my, okay. I'm gonna go out of order on the, I'm gonna go out of order on these questions. And yes, keep them coming if they're not clear. And I think also Mercedes, I mean, Mercedes does not grade them. I grade them, but Mercedes knows. I mean, you should use tomorrow's opportunity to ask her things like that. And she was very. I got to tell you too. Part of the I mean, she's been in communication with me. I mean, mostly about the other whatever. She also uses the lab review time as time to get a pulse on what you guys are worried about and what you're more confident about. And then she communicates that to me. It's actually a big deal to her that I often forget about, that she wants to know how you're all feeling before I post the exam. And she will let me know. And believe me, we're not trying. It's not like she then says, oh, they're all like really mystified by problem 4. So give them two versions of problem 4. Like, we don't do that. We're trying to set it up so that you do well legitimately. So I'm saying also take these questions to Mercedes, but yeah. As I'm looking in the chat, like it's much more about process than final answers. I'm telling you right now, seriously, I'm telling you seriously, two sides of the same coin. One, it is literally conceivable that you could get almost every final answer like wrong. You could actually be wrong in almost every final answer. And but if you have an extensive, thorough, genuine, convincing enough process, a clear enough and thorough enough process, you could still get an A on the exam. Let me say that again. You could have almost every final, and I mean final, like, at the end of the whole problem, you could have a bunch of final answers like wrong and still get an A on the exam, as long as your process is really compelling, which means a lot of the process is correct. I mean, it can't be compellingly all wrong. But I don't even know what that would mean, right? Like, if you follow the process, that's what I'm looking for. Mostly, that's how I grade. I just take off points whenever steps are missing. And if you have all the steps of the reasoning and they're like blah, blah, blah. Conversely, Conversely, you could have all the answers right and not get an A. And I mean, there have been people in the past who had all the answers right and like literally didn't pass the exam and then went bananas. Like, they were so, and I'm talking about people that basically cheated. But I'm saying you could have all the answers right, and if all you have is answers, no, then you don't get an A on the exam. It is about process, and it's really about genuine communication. I cannot stress this enough. Like, I am telling you, and I'll go back in a second, but I mean, hopefully this is helpful. And if I sound edgy, it's just because it makes me as nervous as you. And I hope that's actually, it's not because I'm angry or thinking you're going to do badly. It's that I'm just as concerned about you doing well as you. I mean, maybe not as concerned as you are, but like, the goal is to do well. And my goal is to set up a situation where I feel that you actually do well because you actually have learned or are learning physics. So that also means when you're practicing and stuff the next few days, and then you finally go to present your final copy, like what you're trying to do, and this really is the strategy. You're trying to take any places that you really do understand, the parts that you think make so much sense that you think they're obvious, right? The parts where you think like, duh, like I totally get it. Like there's not much to say. And secretly in your mind, if you're like many people, you might even be thinking, I get it. So there's not that much to get. because like I find Yaverbound very confusing, but I get this. So I guess there's not that much going on here. No, if you get something, if you understand something, you go to town and break that up into as many small steps as possible and over explain it. Don't assume that because you understand something, that means it's self evident or obvious. And this is also where the homework comes into play. If you see something in the practice exam that like reminds you of some old homework, I don't care how many points you got on the old homework, or if you even didn't even get all the feedback yet, or whatever. What I highly suggest, and I mean this, you see something on the exam that reminds you of some old homework, take out your old homework and just look at it just for the sake of taking a walk down memory lane and seeing how confusing you thought that was when you were first looking at it. I am dead serious. When you see something on the exam that reminds you of an old homework, take out the old homework, look at it, and try to remember how confusing it seemed then compared to how clear it might well seem to you now. And what you want to do is teach it to me. Like you want to remember, oh yeah, I didn't see, like when you realize, oh, I get this now because now I didn't get then that average velocity is blah, blah, blah. So now repeat the steps to me that somehow have coalesced to you in that last month. Do you see what I mean? Like you will know that you actually understand something worth understanding and explaining if you can actually remember that you didn't always understand it. And that's anybody, everybody, right? So you're going to over explain the crap that you get. You're going to over explain it. But then what you're also going to do then by doing that is you're going to give yourself latitude because if you get to parts that still are fuzzy to you, like you know what to do, but you don't really still know why. Your friend showed you whatever, you saw it on a video. Then on those parts, once you've already established credibility by really showing me what it looks like when you understand physics, then when you get to the parts that you're a little bit like, then be super honest about them. Literally write in the thing. Then we divide both sides by 2. But honestly, I still don't quite know why. Like, I'm serious. You want this document to be authentic. This is a sharing of your mind. And the more honest it is, the more I believe that if I sat in my office with you and had a conversation about the document, the conversation would resemble the document. Then you've done very well. And it's very distinctly likely that you get an A on it, even if there's a lot of places where you're like, this step, it seems unmotivated to me. But I know we do this. And then and part of the secret for being honest about stuff like that is the minute you start writing it, for a lot of you, you'll then see, especially if you practice writing that in a rough draft, you'll see as you start writing, I don't really understand why we divide both sides by 2. While as you're writing, you'll be like, oh, wait, duh, because it's average. Like that's what happens when you, okay? So it's about process. It is not about the answers. The answers are all over the web and they're all over ChatGPT. Like we both know this. So like it's not about the answers. All right, that's that. Wait. No, no, no. And those of you who are making jokes like, I'm going to regret giving you permission to over-explain, be prepared to read 10 to 20 pages. Ha, ha, ha. I've gotten 10 to 20 pages before. And I'll tell you this right now. Like, do I want to? I'd much rather have 20 pages that are totally clear, inviting, and authentic, and readable than 5 pages of not that. Believe me, that's what I'm in the business for. Now, also, it's going to take me a while to get it back to you, but that's another discussion. But okay. Well, okay. No, that's what you want. God, seriously. I mean, I know you're sort of okay. I'm going to stop with my nerves if I'm making you nervous, but wait. No, yeah, yeah. Whatever I've accepted on homework has been practiced for this. So you do it the way you've been doing homework. Like if you've been doing homework on an iPad, I'm just answering the questions here. If you've been doing homework on an iPad, meaning, with a stylus or whatever, yeah, keep doing that. Yes. But again, same deal as homework. Like you don't write into the questions. You don't copy and paste the questions. You act like you have a blue book. You make a blue book out of either your iPad or blank pieces of paper that you then scan in, but you're just giving me solutions. I hope that okay. No, good, good. Okay, hold on. I'm just answering the questions. I'll go, maybe these are good questions. So hold on, there was something else. No, and then this is not a dumb question. I saw this one earlier. Like even the ones that just say like assign a coordinate. If the question is, it's not a dumb question. Because I get myself into trouble with this. Sorry. If the question is like really like assign plus or minus. If the question's like really straightforward, sometimes it's not possible to break it down into a million steps. That's true. But still, overdo it, don't underdo it. And even things like assign a coordinate system, secretly, what that really is, I mean, that is a step. Like what that's really doing is forcing you to do step one of the larger question. Like, in other words, some of the parts of the exam questions really are they're just making sure that you do steps. So you treat them, you could say something like, this is in effect step one, DFP, here you go. Just over explain everything, really, as long as you're neat and clear. The over explaining is better. Okay, wait. I'm just looking if there's anything else that I didn't see. Okay, I think I've answered all the. And again, and I know you're sort of joking, but I know I get a little like this way around exams. Last reminder, and then we're going to move on. As I say in baseball, which suck at. But as they say in baseball, the tie goes to the runner. You know what? In other words, benefit of the doubt. Go like I'm telling you right now, you should assume it's important psychologically that you assume going into this exam that I'm looking for you to do well. That doesn't mean I'm looking to cheat for you. And it doesn't mean that I want you to cheat. And it also doesn't mean, anyway, it does not mean that. And yet, cheating bothers me, especially when I like to feel like when I'm on someone's side and they cheat, like that's, a little bit of it can feel like a betrayal or something. So I want you to legitimately do well, but I want you to know when you're trying to do it, like whenever you have a doubt in your mind, like this seems too straightforward. I think he could be tricking me. Assume I'm not tricking you. Assume if a question seems straightforward, it's probably because it is straightforward because you need that information for a subsequent question. The questions are meant to like guide you to a final thing that will often be harder. Okay. Like when in doubt, choose the simpler interpretation, but then over explain it. And when in doubt, assume that we're all trying to do well. Don't edge out your friend. Don't edge me out. You know what I'm saying, right? Okay. Now, let's go to the exam. And yes, as somebody pointed out, okay, I'm going to the exam. But yes, that is totally Meowscarada. She was my favorite Pokemon for a while. Well, I mean, ever since Paldea, she was my favorite. I call her a she. I think she's she. Beautiful. I mean, who doesn't want like a Spanish magic cat as their pet? I mean, really. Um, okay, but yes, and yes, she evolves from Sprigatito, who evolves into Floragato, but none of that is relevant and it's all alienating for people who don't care. So why am I talking about it? So, okay, this will be on your exam. You'll get these equations, so don't sit around trying to memorize equations. Oh, yeah, okay, and also, I almost shouldn't have like you'll notice there's choices here on your actual exam. So I'm walking you through right now. Okay. I'm going to get to the big thing in a second, but I'm just like walking you through if anything I can remember to help. Um, on this practice exam, you got choices. Will that happen on your exam? You'll get some kind of choice. Yes, so that what you give me is not as is not 40 pages. Okay, you will get some, but I cannot tell you in advance what your choices are going to be or how they're going to work. So yeah, you need to know everything on this practice exam. Like when you're doing this as practice, ignore the choice part, know everything, because I don't know what you'll be required to. You get my point. All right, but yes, you can assume that your actual exam will not be as long as all of these problems, but know how to do all these problems. Okay, part 1A, and I'm going to go like fly through some of this with just comments, but if you want to stop me and ask a question, feel free. Part 1A, um, part 1A, 1D exercises. Yeah, these are exercises. Perfect example, like you'll get three problems like this as exercises, probably. Um, but of course, I'll not only change the numbers, you have to be careful. I might change certain things that are up to down or positive to negative or whatever. And certain things where it's giving you an acceleration, I might give you a velocity. But yeah, these are exercises. You just have to be careful about them. Is there any real hint I want to, so like an even year, it doesn't say, but you should you have to draw a diagram and do the 5-step method for these. If you have any question right now, you can ask me, or you can go over these with Mercedes, but I'm going to skip them for right now. Now, this one, part 1B, Okay, it says it, but this is the big old duck. It is the big old duck. It's just like turned on its side. And if you can see that, you're already understanding something. And if you can't, you want to re-examine the big old duck in a big way. So yeah, most of it is like build up. Most of it is an opportunity for you to over explain things that you probably think are very well. I don't want to assume you may think a lot of this is like very simple or straightforward. I mean, comparatively, I kind of hope you do, but then it's an opportunity for you to develop the language with me in the document so that by the time I get to the hard stuff, you already have my trust and my real, you know what I'm saying? Again, if you want to stop me here, you could stop me, but I'm just looking. I don't think there's like any tricks or anything, but look back to your big old duck homework to do this one. Um, then the central question, how high was the cliff? Um, right, like that is not the final question of the big old duck. The big old duck was how far back was the duck? But this is what I mean by saying this is all sort of just turned on its side. You're solving for a different variable. But the ultimate key to this problem, I hope maybe is sort of becoming clear to some of you, is the same as the key to the big old duck, which is that stuff is happening in the x-axis at the same time that it's happening in the y-axis, but they're happening independently, right? The whole issue of this is that the weight that is dropped onto the roadrunner, like the weight and the roadrunner have to be at the same point in space at the same point in time. So whatever is happening with the weight has to happen in the same time as whatever happens with the roadrunner, right? I mean, so again, right? So just like a big old duck, you should solve for time first in one axis and then use that time that you solve for in the other axis. And I'll even go so far as to say for this problem, you should solve for time first in the x-axis. Like that's what I mean when I say this is the big old duck turned on its side. Here, you're given sufficient information in the x-axis to figure out exactly how much time it would take for the roadrunner to be where the roadrunner needs to be hit. So you solve for the x-axis first, and whatever that time is, you then plug into the y-axis uh, to find out how high the cliff is. Um, and and here too, I believe. Wait, I'm just gonna look for a second. She's accelerating west. Yeah, just like the big old duck. And people do get this wrong for some reason on the exam. Like she's accelerating west, but while moving, velocitizing east, right? Her initial velocity, the roadrunner's initial velocity is opposite to her acceleration. That means if she keeps doing what she's doing forever, if she maintains constant acceleration, she's going to turn around, right? She's going to go like that. So it's just like big old duck in that there would be more than one time. There'd be two times that she's at the appropriate spot for a collision. So there are going to be two answers to this for the height of the cliff, uh, unless we get to part E and we change the acceleration to be in the same direction as the motion. And then there'll only be one answer. So I'm like giving away a lot. I don't, okay, I'm just saying if that hand I think is my hand, right? But let me know if there's but now the thing this problem right here, I will probably walk through with you on Wednesday of this week. This problem is a amazing example of simple, not easy. Like there's like two, if you do it right, there's like three lines of math, but you have to explain a lot. All right, I'll just say this. Hopefully I'll talk about this on Wednesday, but this is a real physics problem. And it's a real example of how to do this exam sort of properly. If you really understand the physics of Galileo's principle of relativity, and you really understand that you can choose the perspective in which you solve a problem, then if you choose your perspective correctly to solve this problem, and you make your choice clear in the document, then you'll have very little math to do and you'll get the answer very quickly. If you don't choose your reference frame consciously and wisely, you'll have a lot of math to do and you could still get the right answer possibly, but I've almost never seen anybody do it. Like there's so much math to do that it's like really easy to make a mistake and get the wrong answer. So and again, I'll probably talk about this Wednesday, but you could talk about this with Mercedes tomorrow. My huge warning to everybody about this one is once you get how to do this one, it can be like a great opportunity and like for many of you because if you understand how to do this one, you'll focus on really on drawing good pictures and explaining to me concepts and explaining to me in English. Like even if you've been feeling shaky about calculus or computation, you could go to town on this one and totally nail it, and it's very little math. But you have to understand the physics and you have to really explain your choices. This is a common example where if I just get 3 lines of math that happen to have the right answer, then I know the person doesn't actually understand and they basically just copied from someone else. And then that's not sufficient. I'm just, okay, this is an opportunity to go bananas and really do well without a lot of computation. But you have to show me that you understand how you set it up so that you didn't have to do computation. All right, I'll leave it. Okay, pro tip, just to make your time worth it. I'm going to tell you right now what I always look for when I'm grading this one. If you do it correctly, you're going to end up saying, and you might not have even looked at it yet. I know that, but just write this down as a pro tip or whatever for as a reward for paying attention to me, because that's what I need in life. Um, the thing that separates the women from the girls and the men from the wheat from the chaff on this one is there's some point in the explanation in the solution where I say the distance up is the same as the distance down. And you need that in order to simplify a lot of calculations. It's like true, but it's totally not obvious at all. And anybody who just treats the distance up as the same as the distance down, if they don't literally stop and make a big explanation as to how they came to that conclusion, that is a giveaway to me that the person is cheating. I mean, like not cheating, like I'm going to take you to court, but like that's a person who's cheating themselves, who doesn't understand. If you get to the point where you hear on Wednesday or you hear from Mercedes or you hear from a friend that the distance up is the same as the distance down, you better stop and really, first, my advice is ask yourself, why would someone not think that? Like first see why that is not the obvious thing to think. And then once you see why it's not the obvious thing to think, then guide yourself through why it's, even though it's not obvious, it is correct in a certain perspective that you would want to take on this problem exactly so that you could come to that conclusion. So that's a big hint is you want to take a perspective in this problem that would allow you to say distance up equals distance down. You want to be able to see why that is not an obvious thing to do, but it is a correct thing to do. And if you could explain that, you're on the road to nailing this problem. All right, that's what I'm going to say about that. All right, now this one, I know I only now have you know, what, 20 minutes or something, but this is the one I want to spend the next 20 minutes on. So I'm gonna switch the screen share in a second. I'm gonna keep on, and again, in the interest of time and in trying to like get you answers, I'm not gonna write all the steps right now. Maybe I'll be able to do that on Wednesday, but like that's up to you to write out steps. Like, but I'm gonna bang through like so this problem is like the centerpiece. This is like as hard as it gets. I mean, this is the hardest thing in the thing, I think. And it's the most physically and computationally heavy problem in the exam. And it's the material that we were just setting up last Wednesday. What this is about is what was on the front page of the notes today, like the blackboard when we walked in. Like this is about adding velocity vectors. And in order to like adding two velocity vectors together to get a third, that's what this whole problem is ultimately about, or at least the hard parts of it are about. Okay. And in order to add two velocity vectors together to get a third, you really have to have gotten your mind around two things. You have to get your mind around the computational, like mathematical method for adding vectors, the method that is easier to see with displacement vectors, the method we did last Monday, the method of components, where you take each vector and you break it apart into an X and a Y piece, and then you make an XY chart, and tally up, no pun intended, you Yaverbaum up those components and get a final X and a final Y, and then you put those together in one big old right triangle, and you do Pythagorean theorem to get the final answer. I mean, I just said that quickly, but hopefully that's how you add vectors by the component method. So you need to know that to add velocity vectors, but then you also need to understand Galileo's principle of relativity. You need to understand that to add velocity vectors is necessarily to be analyzing more than one frame of reference at the same time. You add a velocity as measured in one frame to a velocity that's measured in a different frame in order to get a velocity that's measured in a different frame. Like velocity of me relative to you plus velocity of you relative to Earth gives us velocity of me relative to Earth, right? And why you need to know that to know which velocities can be added together to get what. So you have to, okay, so this really puts together physical conceptual recognition with graphical and symbolic computation. Okay, so you'll right away. So I'm going to start reading it through, and then I'm going to switch. And again, if I don't finish it today, I'll finish it Wednesday and then do the other problem Wednesday. Both of them are about Galileo's principle of relativity. So a boat travels down a river, and I'm watching the chat. You could stop me anytime. Lost you on Yaskarada, huh? Okay. You gotta, I mean, pal, that, okay. Anyway. A boat travels down a river. Relative to the water, the riverbank moves at a constant speed of 3 in a direction of 45 degrees southeast. Relative to the riverbank, the boat moves at a constant speed of 8. So notice, just note, this is a class, like on your exam, maybe it's not a boat, maybe it's not water, maybe it's other things. But notice there's 3 objects here. There's 3 frames of reference. What I would do right away, if I were you, is like, I mean, of course, I would draw a diagram and all of that. But then underneath the diagram, after labeling like the facts that are given, I would say something like, let R equal river, or, well, yeah, and let W equal water. Sorry, that's the same thing. I'm sorry. I would say something like, let W equal water. And then river, there's like a lot of R's and B's and B's in here, so it gets confusing. And I apologize for that. But like, what does riverbank mean? It means the shore. It means the land, right? So maybe use a letter like S for shore or L for land, just so it's like totally clear. So say something like, let W equal water, let S equal shore, and let B equal boat or something, but make a clear thing right at the beginning. Because now what we're going to have is a bunch of velocities that have double subscripts in them, right? You're going to have something like V of, like here, the facts. Like you could even write these right under your diagram. Like it says, relative to the water, the river bank, i.e., the shore, moves at blah, 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 blah. So what does that mean? That literally means, and I would write this before doing anything, I would write something like V, with an arrow above it, V S W equals 3 meters per second at 45 degrees southeast. Let me say that again. VSW, meaning velocity of shore relative to water. And notice that, like already that's confusing to some people, or I don't want it to be confusing, but I want it to be clear. But like don't get hung up on the order in which the English words were presented to you. It's not about the order of the English words. It's about what is relative to what. It is telling you when it says relative to the water, the river bank moves. That means if you were sitting in the water watching the riverbank, if you were a water molecule or whatever, like a feather, like something that's just like floating in the water. If you're in the reference frame of the water and you're watching the shore, you would observe, measure the shore going 3 meters per second at 45 degrees southeast, right? Now, right? That's what that means. Relative to means in the frame of reference of. It means compared to. It means if the water regards the water as at rest, then what the water observes is the shore doing blah, 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 right? Uh, and I hope you're starting to understand. Like this is why physics is physics. You may, if you're still getting used to this stuff, I totally respect and understand. If you read that, that's like a jostling fact to read. Like it's not necessarily the way people always look at the world. Most people would stand on the shore and watch the water. They wouldn't look at it from the perspective of the water. But what we're trying to reinforce right from the gate is that the shore is just a perspective. It might be the one that you're more used to, but it's just a perspective. Just like looking at the universe from the perspective of Earth is just a perspective. It's the one you're used to, but that doesn't make it objectively correct, right? The shore can look at the water, and that's what you're going to see in the exercises that are about to come. The shore can look at the water, or the water can look at the shore. And you may be more used to the shore, but you may also find, and this is the thing of physics, that in many contexts, look the water may be the more convenient way to look at things ultimately, and it may reduce calculations, and it's not less correct than the shore. Just like the earth, you get okay. So the first fact is that so v, but order does matter, right? So v s w equals 345 degrees southeast, and then under that I would write like v b S. Sorry. Yeah, VBS, the boat relative to the shore. Now that's like more of a normal kind of thing to say. Like that's what, right? But it's just as valid as the first. We're just trying to show. Okay, so you have two velocities. You have a V R W. You notice V. I'll start writing on the thing because I'm getting myself confused too. But before I go any further, I just want to say, even if I don't know the questions, like everything I said about A, B, and C last Wednesday, A, B, and C are just arbitrary letters. They stand for anything. In this case, I mean, if you really wanted to, you could say A stands for the water, B stands for the shore, and C stands for the boat. If that makes you more, I don't really want you to be that rigid in your thinking, but like you could. But now anything I said about A, B, and C applies here. Like even before I start getting answers, I want to tell you, if you're following what I said last week, automatically I know, for example, like follow the pattern. I know VAB plus VBC equals VAC, right? Me to the subway plus subway to the street equals me to the street. I know that is true, like always in physics. So I automatically know velocity of the boat relative to the water plus velocity of the water relative to the shore is the velocity of the boat relative to the shore. Hopefully you see what I'm going to say that one more time. They're going to move on. But I want to say that is true whether or not the problem's asking for it. I don't know what the problem's asking for yet. But I know velocity of the boat relative to the water plus the velocity of the water relative to the shore is the velocity of the boat relative to the shore. So I could set if that right, I could just start setting up vector components and adding, and that would be true. I don't know if that's what the problem's asking, but I also know just as equally velocity of shore relative to boat plus velocity of boat relative to water is velocity of shore relative to water. Like anything that fits that pattern of ABC is correct. The question is, which one am I going to need for this problem? So that's where reading comes in. But hopefully you are starting to see that big picture. All right. So relative to the riverbank, in what direction is the water moving? All right, what is that? All right, I'm gonna switch. Yeah, I'll start. I'm gonna switch. I'm gonna start writing now. And I know we only have 20 minutes. Why is my hand still up? Hold on. Um, okay. So these two statements right here are a summary of, if you really understand all the implications of both these statements, you know how to add velocity vectors and you know how to do the thing that I'm like doing right now. But maybe you don't. But there's still time. So wait, I'm just okay. Um, so I guess I'm gonna okay. So again, I'm not well, you see what I'm saying, right? Okay. So I'm saying among you're gonna make a full picture and all that. I'm not doing that right now to sit, but you do. But what I am gonna do right now to make clear, um, um, okay. So this is a quick, right? You should include more, but one thing I'm trying to make clear is my little legend of initials. And I'm saying, okay, the two vectors that were given is 3 meters per second at 45 degrees southeast, and that is the velocity of the shore relative to the water. I've changed the word riverbank to shore just because there's too many R's. It's too confusing. Okay, do whatever you want. And then velocity of boat relative to shore is, yeah, is 3 meters per second, right? So notice both of these vectors have been given in two different frames of reference. I'm just saying, right? So that's like some of the givens right there. So then in A, relative to the riverbank, in what direction is the water moving? So what they're asking there is the velocity of the water relative to the shore, but they're just asking like theta, right? So that's the question there, right? That, and you write it your way, but basically they're asking the direction of the velocity of the water relative to the shore. So here's my point for step 3, GDP. Like even this, and this goes back to something someone was asking. Like this seems like a really like quick question. I mean, it is comparatively quick, but how do I even know how to answer it? The thing that I want to say here, if I'm you, is and you would expand this, over explain this, especially the first time that you do. But notice, note GPR form number 5, case 2. I'm not kidding. What is that? That is, in general, the velocity of me relative to you always equals the opposite of the velocity of you relative to me. That is the two object case of relativity, right? The one object case is that the velocity of me relative to myself is always 0. And the three object case is the one that we're going to use to solve the hard part of this problem. I know I'm going a little bit quickly now, maybe, I don't know, maybe exactly at the right pace for some of you. But I'm saying they are asking in the very first question, what's the water doing relative to the shore? I don't freaking know. But what I do, I don't explicitly know. I wasn't told, but I was told what the water is doing relative to the riverbank. So what I got to do in my mind is just flip it, right? And the thing is, that's a physics reality. It's not hard. You probably, if you were forced and paid money, you'd probably come up with this on your own anyway and just not know it's physics. And if you overthink it, you're going to think I'm trying to trick you. I'm not, but I am trying to say, wait, this is a physics principle. The principle is the principle of relativity, of which we have now. And that the original form of that principle is the laws of physics are the same in all inertial reference frames, in all unaccelerated coordinate systems. I'm going to move on in a second. I know we got to get to the meat of this. And again, if worse, we'll get to the meat of it on Wednesday. But as far as how to take this exam, etc., here's an opportunity right now. Let's assume this is the first time you're discussing any of these things in the exam. I don't know what order you're doing the problems in. Right here, if I were you, I would stop and actually explain what GPR form number 1 is. You don't have to explain all of it, but explain the original concept of relativity. Maybe even make reference to we don't feel it, even though the Earth seems to be going 65,000 miles or whatever. And then get your explanation and me to the point where I understand in English, therefore, velocity of Earth relative to sun, what example, is the opposite of the velocity of the sun relative to Earth. That's what I'm saying here. That's step 3. Therefore, so over explain it. You don't have to every time from here on in, but if it's the first time it's coming up, over explain it. Then step, kind of like I do in class, for good or for bad. So then step 4, right, is here. Here we know that the velocity of the shore relative to the water is 3 meters per second at 45 degrees southeast. Thus, here, VWS must be 3 meters per second, same speed, but at 45 degrees northwest. You flip the vector entirely. It's that's what the negative sign means. Negate both the x component and the y component of the vector. So step 5, final answer circled. And notice the question. The question is only asking about direction here. So the answer is theta for water relative to shore equals 45 degrees northwest. That is the answer that the question is asking. That's the answer. Right now, I know we have 11 minutes. That's a recommendation of what I'm looking for to how to answer even a seemingly straightforward. And I'm not saying, look, I don't know what's easy and what's hard. Nothing is easy until, you know what I'm saying. Everything is hard until it isn't, and then it seems stupid. But that's a question that's not a big question. Two things to note are it's not a trick, but you need the information for later, and it's an opportunity to really explain why it's not tricky. So there you go. Now, I'm not going to do that every time now. I'm going to say, for B now, B relative to the boat, how fast is the riverbank moving? All the same logic. You could say C above, C above, C above, if you like. But the answer for this, How fast the river bank going relative to the boat? Well, that's 8 meters per second. If you see the above logic, or if you don't understand that, look at it at home or look at it with Mercedes tomorrow, and I think you'll see. Then C, from the water's frame of reference, at what velocity is the water moving? That's case one. So I'm scrolling things out now. Just like, okay, you keep writing step one, step two, but like in general, this is true always, right? That's a step, like that's step three, right? That is GPR form 5 case 1. Therefore what? Therefore the velocity of the water relative to the water, anything relative to itself is 0. That's step 5. Okay? Stop me if I'm okay. But now the real question comes. 9 minutes. The real question comes here from the perspective of, so D, from the perspective of the boat, at what velocity is the water moving? Yeah, yeah. So they want to know the velocity of the water relative to the boat. Like that is the question. Now that is a big question. Again, yeah, to be clear, it's big enough. I'm not sure that I can go all the way from the beginning to all the way to the end in these next 8 minutes. I'll pick up on this Wednesday. And for that reason, I'm going to try to give you the summary right now. Well, yeah. So first, I don't know why it goes 3 and then 4 instead of 1 and then 2. Sorry, that's just like a typo. But it wants you to find it graphically and then numerically. Graphically, what that means is to add vectors, place them tip to tail. Okay, that's what graphic. It doesn't mean a graph. It means visually. Okay, and what it's and here's where I would be much more like the more you can be to scale here, the more you can actually be careful and use a ruler or even a protractor, the more your diagram is going to reveal the actual proper answer to you. So that then when you try to do it numerically in 4, 3 and 4, these two parts of D will act as checks on each other. And now again, of course, this is an example with you are going to have this problem on your actual exam. I mean, that's why I'm walking through it right now. Okay. And probably you won't even have a choice about like, I don't know, but this problem will certainly be on your exam. But of course, I'm going to change the numbers. And what is going to be given is going to be like I might give you 2 velocities in the frame of reference of the water. And then you have to know which to put together to get what. So that's what this part is sort of a test of. But if you make a drawing that's correct and careful, your third vector in the drawing will show you right from this part what you're looking for as an answer to your computations in the next part. Like it will, you see what I'm saying? So both of these parts will serve as checks on each other. If they're both consistent, you're doing something good, and vice versa. So let me try to make this just a little bit neat on the other page. Okay, you're looking for the velocity of the water relative to boat. So how can I possibly get that? Well, one thing I know, like this is where I have to be thoughtful about physics in order to set up the math. So I'm using GPR form 5, case 3, the 3 object case, right? And what that says is if I want to know the velocity of some water relative to a boat, there's various things I could do. One thing that would definitely work is the velocity of the water relative to the shore plus the velocity of the shore relative to the boat. Please notice that's a big thing that I just wrote down. Hold on one second. I just want to see something. Yeah, yeah. Right. Or, right, wait, so that's a true statement. If you wrote that down, I would be like, yes, and give you many points. I still don't even know what you're going to do with it or what I'm going to do with it. I don't know exactly. Like, I don't know how it relates to the givens yet. I don't know how to make it relevant yet, but I know it's true just because the pattern of the letters, like it's following the ABC pattern. You have to understand that physically, that statement is true. But I might notice, you might notice, and again, we will pick up with this on Wednesday, I promise, but you might notice, and we'll get straight to it, I think. Um, you might notice if you look at that, like, all right, that's true, but I don't like it because, like, W to S, was that even given in the problem? Technically, no. Um, S to W was given in the problem. And was SB given? No, technically, no. BS was given. So you either you're gonna have, the way I'm gonna do it, I'm gonna have to flip each, like that's why A and B were sort of leading you up to this. They were getting you to realize, oh, if you need SB, just flip BS or right or whatever. Right? And that's what I'm probably going to do in a minute. But or if you don't like that, there's other things you could say too. You could say something like VWB equals the flip of VWB. Let me just say, or right, literally there's options. And these are not the only two options, but you have to write what I'm really trying to stress here with 3 minutes left is you've got to write down a statement that is true from the standpoint of physics. That's the point of step 3 always. Then in step 4, you tweak things or you do a math to make it relevant. Don't do what people often do when they panic or unconsciously when they get used to. Don't write something relevant and then try to make it true. You can't turn a falsehood into truth. You write down something true and then you make it relevant. I'm really serious about this. so, so, so I could do either one of these options. I I can do either one of these options. I'm just gonna set up the diagram. We have 2 minutes and then I'll do the computation part like on Wednesday. But I'll call this option 1 and I'll call this option 2, just so I can be consistent on this page. Option 1. Option 1 tells me to add WS to SB. So what would I do? WS to SB. I would first draw a vector that is, first I would draw a vector that is 3 meters per second to the northwest. And then from its tip, I would draw the tail of a vector that is to the southeast. Right. And the answer will be that VWB. This is a diagram. So this is one option, and it's 1205, but that is one option. Yes, that is one option for part D, part 3. That is what it would mean to graphically represent what's going on. And if I did it to scale, then that white vector that's left over in the end is what I'm looking for when I do all my computations. Like I would hopefully get an answer that was pointing to the southwest if I did this all to scale. That's the idea. And what are the computations? They're all take each component, divide it to X and Y, make a chart. And that's what we'll do Wednesday. But that's the idea of this. I will leave it at that. I'll just look at it, but I'm going to turn off the recording. Okay. And if you want to stay for a second and ask questions, I'm not leaving. I'm just turning off the recording. Oh, yeah. Sorry. Wait. Someone put in the chat. Yeah. Okay. So yeah, someone wrote in the chat, is that why perspective matters? Because we can't find WB if we use the original values. Right. Like the whole perspective thing, Matt. Yes. I mean, that's why perspective matters, to know what to do with these original yes. Yes. Okay. Goodbye. Bye. Thanks. Yes. Okay. Uh, you're all very good people. I'm gonna stop. I'm still here, but I'm stopping the recording and blah 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 blah.